There you are now. Welcome back to the workshop. So on today's episode, let's take another look at our RTS clutch jig. Since you've seen me last, I've been doing just a little bit of work with it. I haven't gone mad. I didn't do loads of stuff that you didn't get to see. Just a few little things. I made up that pin that we talked about there. Billy will give you a close up of that now in a second. I laser cut the disc, again thanks to Ben who came up with that idea, and had to do a little bit of jiggery pokery with the disc. I'll show you now in a little clip in there. You can see we had to do a little bit of work to try and make the disc center up on the boss. Then we had to do a little bit of work to get the disc running true. Back now at this, and you can see we have the disc running fairly true, and when we turn our arrangement here, it's moving pin to pin. I turned up this little guy here, which is just a piece of ground gauge pin, and I've turned two diameters on it, 6mm and 8mm, and it's 10. I'm kind of thinking that it fits into that hole there nice, and then kind of locks up our slip disc there. What I'm thinking is I might just weld like a little eye or something on it, so that it'll be real easy for me just to pull it in and out as I'm going along. I might, that would be nice to have something there to just, you could poke it in there and it would hold it. Even on the bit of plywood that we used, our laser cutter obviously can't cut steel. It's only a kind of very basic one, but it can certainly cut plywood. And even on plywood, I'm amazed actually just at how little run out there is on these pins. Now the way I set it up was I used the T-slot here to make up this sort of truing pin, but actually because it's nine rivets hold this on, it's actually going to be a case that it's not actually all going to line up dead in line. I kind of thought in my head for some reason it would all line dead up in line, but that's not the case. Doesn't really matter. All we have to do is center up on a pin, or should I say on a rivet, and see then if we start moving this one by one, do we start hitting our centers and if we're in the right way. I have over here in an R8 collet, I have a 5mm carbide drill bit in there, which I'm thinking, I may not do this always on this, but right now while I'm in sort of full learning mode, I'm thinking the most rigid setup I can get here and the most rigid setup here, I can get the most accuracy. Now, when we move forward in this clutch arrangement, the next thing, once we get these drilled out, we're going to end up with a diaphragm spring loose from the arrangement and sort of 6 bits of a rivet, or say 9 bits of a rivet. I'm absolutely taken by calling them 6 rivets. There's 9 rivets sticking up. Those rivets have two major jobs in this clutch setup, and I'm going to explain this more and more as we go on. The first major job they have is obviously holding a preload onto this bevel spring, and the second thing they do is they have a collar on the inside which is spacing the bevel spring such that it sits in the kind of unloaded position, and then when you bolt this down to the flywheel it will flatten out, okay, or in theory should flatten out. When we're going ahead and making this into our RTS clutch system, what has to happen is those rivets have to be drilled out. The holes that are left from them have to be drilled and tapped. M8 I think is what's going to work here. And then we have to make up spacer collars that are going to go in underneath each one of these holes, so that when our bolt comes through from the top, the collar will allow us to get the bolt down and torque it and put preload on this spring. I've been doing a good bit of thinking about this and the different ways that we can do that. I think the collars are probably still one of the better ways. However, I'm going to visit this ring here that goes down. Underneath this ring is a wire which allows the piece of hardened steel wire which allows the spring to pivot. It kind of acts like a bearing, and this here is just a way of loading up that spring, the ring on the inside, and an angle is formed between the outside of that ring and the bevel spring on the inside when it unloads. I may well actually look at drawing up this ring here in CAD and then using my fantastic local laser cutter to laser cut me out something better than this, maybe a little bit thicker with a better metal on it. But that's all part of this sort of rapid prototyping and looking at this kind of design. There's other things I want to look at with you, the likes of the driving straps here and how strong they are and what way they're going to go. However, let's just get this centered up first. So we have our pin in there. I'm going to bring the milling machine bed over and we'll center up on one of these pins. Wish that had went in fast forward for me. You guys get the luckiness. Okay, center up on one of these pins. Now there is actually a little kind of divot in the center of these, almost like a center punch. So for us that makes it a little bit easier to kind of get lined up and to see where the center of this rivet is. I think that's looking pretty good. Okay, what I want to see now, let's just bring that quill up, take out that pin and go one hole here, which takes us to that one there. Let's gauge that up and see what that looks like. Okay, that's really nicely on center there. Let's go for another one. Get a gauge pin in there. I probably, had I been thinking, should have made this disc a slightly bigger diameter. I'm kind of getting caught in here with the edge of that diaphragm. So I think if I do send this to the laser cutter, I'll go and make that a little bit of a greater diameter. Okay, we're dead on center again there. So somebody got their drawing right, amazingly. And we're on center on that one. A small bit of drift there on that one. So now the question is that drift in our... Yeah, see, we're drifting just slightly there now. So that might just be... We had one small problem when we were cutting this in the laser machine, and that was it didn't cut through right the first time. Okay, we definitely are suffering a bit of drift there, all right. This is all part of prototyping, guys. You don't get it right first time or get it absolutely perfect first time. You got to do a little bit of adjustment just to get the thing where you want it. You'd be nervous if it worked perfectly the first time. Okay, we're on center there now. Okay, interestingly, that one is right. We're starting to get back around to our original one now. I think the next one is our original one. Very close there to center, all right. And then that one's back on center. Okay, that's interesting. So what's happening here is this disc that we have machined up, there's a small bit of drift on these center holes. And what that basically means is that the holes that we have machined here are not all actually 100% where they are. Now, how I did these holes is I interpreted them as a bolt circle off the center here. And we measured the distance apart of these using a calipers. The possibility is that I didn't get the measurement exact. Now, if I'm out by maybe, you know, 0.2 or 0.3 of a millimeter on the distance between each one of those pins, as I'm drawing this in the laser, or sorry, in Fusion, that is going to give you drift, because each one you move, or every time you move on one, you're going to be out by 0.25. And that kind of makes perfect sense to me, because as I move this around pin by pin, or as I go pin by pin, if I lift this and go on to the next one there and put my pin in, we're just nearly almost exactly on center, but we are moving slightly off center. Then as I go to my next one here, if I lift up the drill bit and go on to my next one, now that there would be dead center, but I can see that I'm out here now by, I'd say, probably a half a millimeter, which that'd be right. If I was 0.25 out on one, then I'm 0.25 out in the next. 0.25 is half a millimeter. Then let's have a look at our next one from there. Okay, now we're sort of a millimeter, maybe, yeah, almost a millimeter, maybe another 0.25, which would make sense. Then head to our next one here and come on to that one. And now we're probably the guts of a millimeter out, which that would make exact sense. So what I'm going to have to do is, when I drill this the first time, I'm going to center punch each one of these and drill them in situ, or drill like this. And then once I have this out, what I can do then is I can make 2 gauge pins to go down where the original rivets were out of ground stock like this. I'll make 2 gauge pins that sits in there perfectly, and I'll then be able to measure with the micrometers across the inside and then, or sorry, the outside 2 diameters. And once I measure across the outside 2 diameters, I'll be able to get accurate to 100th of a millimeter then with that, and then we can interpret that as our bolt circle. So I think as a proof of concept here, from the point of view of, is this going to work? Are we going to be able to use it to center up on our pins? I think we have definitely proved our concept well here. And I think, you know, usability and ease, yes, I think that's going to work. That's going to be more than enough to hold that so I can drill it. So from that point of view, I'm very happy. I think proof of concept is good, and this is what rapid prototyping is all about. We now know, make this a little bit bigger in diameter, which will bring this out here, will give me easier access for putting this gauge pin in and out. And you know, the easiest thing to change here is a drawing. That's going to be only minutes of work to get that drawn to work. So this just shows you, not everything works first time for me. That's the way life is. Life is real like that. What we can see is that we need to do a few little adjustments, but we know exactly where we've gone wrong. Now, the next thing I want to do is that we've proved the concept that this works and we're very happy with it. The next thing I want to do is I want to test this clutch kit before we take it apart, because I want to just see how much load it actually has. So what I'm going to do is I'm going to unbolt this off of our jig, and I'm going to put it together with a flywheel. And then I'm going to bring you back and we can do some torque tests and see what kind of power this can hold. I've gotten to the stage now where I have this clutch setup fully assembled. Now you'll notice there's one piece missing, which is the spigot here for connecting the clutch to the crank. There's no need to do that in this assembly because we're literally just testing the holding power of this clutch. We don't need a crank involved in it. Now straight away I bolt this up, and I've torqued my bolts here to 30 Newton meters, which would be kind of around the finished torque. These are 10.9s, so technically speaking the finished torque for these would actually be 40 Newton meters, but at 30 there's more than enough to hold it. One of the things I want you to notice is this is the Mini Spares uprated steel road flywheel, and obviously this is the turbo diaphragm. What I can see straight away here is that this diaphragm is not completely flat. What we'd want to be doing here is taking a couple of millimeters off the horn heights on the flywheel to drop that diaphragm into full compression. If we went and did a compression test on this now, what we would feel is quite a heavy opening pressure versus what it could be if the horn heights were brought down a small amount, like we did in our other clutch video. And I'll put a link to the clutch video up in the corner of the screen there now. Actually, I'll do a link to the playlist and you can have a look at that playlist. It's for a Verto clutch. Sorry, it's for a pre-Verto clutch. We will do setting up a Verto clutch as part of this video series. But right now, for what we want, I just want to assemble this exactly as you guys would if you bought it off the shelf in Mini Spares or any of the other mini specialists. This is the Verto clutch setup standard. The plate I have in this is the AP Road Race plate. Now it is a 180mm plate, but the plate itself is a much higher quality plate, and I find that these hold more torque generally than the 190. I have a 190 sort of turbo plate ordered. It just wasn't in stock at the time, the last time. I have that ordered and it's on its way, so I will test one of those with another new diaphragm for you as part of this series, just to make sure and see. But they are the ones with the kind of springs and stuff in the center of them, and for really high powered applications this is a much better plate. I've been using these AP Rally plates for 15 years at least now, and I know the reliability and strength that's in them. So there might be a little more holding power with a slightly bigger diameter plate, but to be honest with you, I've never found that in all the pre-Verto testing I've done. I've used the bigger plate, and because the friction material isn't as good in the bigger plate, these always hold more torque. So it's 6 of one and half a dozen of the other in most cases when it comes to the diameter of the plate. But I don't rest not, I will do a 190mm plate to make sure that I am right on that with a Verto setup. So let's get this up into the vise. We're just going to use the vise here in the milling machine. It's easiest for you guys to see, and it has great holding power. It's a machine vise, so it's very, very strong. So we'll just get that nipped up. We've got the plate just centered up on the flywheel. There's no need to have it, a 1,000,000% in the center. It won't make any odds. Like, it's centered up there with that boss, so that's more than good enough. We made this up, you can tell by the rust. It's been around for a while, and we use this just to test torque on these. One of the things I love about these AP plates is just how well that driving boss is affixed. Look at the amount of rivets around the outside of it. It's just proper good class. Just before we test the torque on this, just want to say thank you very much to anybody who is new to the channel. You are most welcome. Thank you to all of my subscribers. You guys are fantastic. We're starting to head towards another little milestone for the channel, 4K subscribers, which is amazing. The channel is doing really well at the moment, and I'm really, really impressed with it. Thank you so much to everybody. The feedback on these clutch videos has just been fantastic. Everybody is commenting and getting in there and really encouraged me. I was actually genuinely excited to get out today and film this for you. So it's really, really good. Billy's reminding me that you're going to see this on a Wednesday. And I'm filming this on Saturday. Tomorrow we have a live, which is actually last Sunday for you guys. That's some Inception stuff there. Brendan, our mind, when we're going to be on with Cole, so I'm looking forward to that. But I got out today and filmed this because I was just really, really excited to test this. So, oh, what's that? Did you say a new torque wrench? Did I buy? Oh yeah, just these actually, by the way, are one of my absolute favorite torque wrenches. I get these from a local company. They're made by Sykes-Picavant. I'll see if I can get a link for you and put it in the description down below. These are fantastic. It's the big brother. This is well, let's see now, what is its range? Oh, 60 Newton meters to 300 Newton meters, which is phenomenal. I have its little brother then, which I think might be over on the bench here. My apologies. Yeah, have its little brother here, which is the 20 Newton meters to 100, and I have its really, really baby brother in here somewhere. Ah, there he is. Thank God Billy fast forwarded that bit for you. Whew, lots of me faffing around inside the torque wrench drawer looking for it. And that's its little baby brother. So that goes from 3 Newton meters up to, I think it's, 3 up to 20 Newton meters. So that's the kind of torque wrench range I use. As I said, I'll try and put a few links in the description below for anyone who's interested. These are actually made by a company called Norbar for Sykes-Picavant, and they're probably known as the single best torque wrenches in the world. I get these calibrated. I actually have a calibration machine for them. I'll do a video on calibrating torque wrenches at some stage. You really should get these calibrated by the manufacturer or by the person who sells them to you. But I calibrate them myself in-house here because I need my accuracies to be through the roof. And both this one and this one I've had for probably 10 years, maybe a little more. And every single time I test them, they're always within a quarter or a half Newton meter of what they were when I set them the last time. So the accuracy in these is phenomenal. Obviously, you got to wind them off every time when you're finished with them, so as not to leave tension on the springs inside. But other than that, they're fantastic. So, well, I don't know. Let's pick an arbitrary figure here to start out with and see just exactly what this clutch plate can hold. I suppose let's start with 90 foot-pounds. I mean, that's a kind of good place to start as any, I suppose. And I'm going to pull down the way. It doesn't actually matter whether you go up or down the way with this. It's just handy for me for filming and whatever. But, up the way is the same. And just to prove that, I will test it up the way as well, just to show you. So let's try 90. Okay, so that's holding 90 there without, yeah, no problems whatsoever. And just to kind of prove, as I said, the up the way on it. It is just easier for me to go down the way, but there it is in up the way. It's doing the exact same. Okay, let's actually, maybe that's better for film, as you can see. So just zoom in on that one, Bill, and we just showed them the 90 foot-pounds there. Alrighty. So we'll try 100. and see, can it do 100 foot-pounds? A lot of good mini engines out there be making around 100 foot-pounds. So let's just see, can it hold 100 foot-pounds? Okay, holding 100 foot-pounds there. Let's try that down the way now and just see, is it still holding 100 foot-pounds? Oh, interesting. So in that direction it isn't holding 100. Let's try that back up the way again now just to say. Might have just ruined my own theory here. That's interesting. So it'll hold it up the way but won't hold it down the way. Yeah, it's definitely slipping at that. I wonder if it's just the case that it's a bit of stiction that's going on. Wait till we just get it to turn up the way. Yeah, it is just a bit of stiction because we can see it slipping there. Okay, so maybe just the torque reaction coming down the way just gets over that. Yeah, it's definitely slipping at 100. Okay, let's come back off 100. So let's try 98 and see if it'll hold 98. Now we always have to just give it a little slip first. Still slipping at 98. Let's try her at 96 then. Let's see, will it hold 96? It's just still slipping there at 96. So it's holding there at 92. Now let's just see up the way at that 96 again, and I think we'll take an average of both. So definitely holding there. Let's come up then to 94. So just about starting to slip there at 94. So I think the average across the board there is, we can say, looking at it up the way, it started to kind of slip at 96, hold at 94, definitely 92. Sorry, that was down the way, and then up the way, it seems to be a little bit more likely to hold it up the way, which is interesting. I wonder why that is. It might be something to do with the design of the clutch plate. I'm just looking there. There is grooves machined into the clutch plate, which I'm turning against up the way as opposed to down the way. So, that's interesting. I'm just trying to think now. The flywheel is turning that way, so the torque reaction is going to be that way. It's interesting. Yeah. Okay, let's take the average of the two of those. So the average of the two of those, we could say, is going to be split it down the middle. It's going to hold 95 foot-pounds of torque. That's what it's going to hold. And if you're kind of breaking over 95 foot-pounds of torque, this thing's going to start to want to slip. Now, remember, this is a static test, okay? So you might well find with everything that moves and everything goes, this might well hold 100, you know, in a motion test where everything is moving. But we're doing this much more to get an idea of what's going to happen when we tune this clutch, and then when we make it an RTS, when we make it twin spring, and where we're going with that. Now, the last thing I want to talk about, and then I'm going to go back over to my jig here and I'm going to drill out these rivets. The last thing I want to talk about is the idea of tuning these. So I have went through my own stock and I found a bunch of Verto clutch covers that I have, all different pressure plates. Now, some are different spring manufacturers. Some are Valio, some are Borg and Beck, and some are Look. I'm going to be interested to see what the differences in all those different springs are. Over the next while, I'm going to do a bit of building up and testing of these. I might do it in shorts rather than doing them in the main channel, but I might do a conclusion video where I go through all the different sort of setups and the different torques that we can get. My idea, or what I would really love to do here, is to be able to build a very specific clutch cover, or maybe even a small range of them, where we could say go from, because we have the ability in here in-house to make clutch covers to anything we want. So what we might have is we might have a couple at say 110 foot-pounds, 130, 150 and 190 or something like that, or we'll go for, yeah, I'd say 190 is probably as much we're going to get. We might do a 200 one, we'll see what the demand is. But it would be nice to have that, because if we had ones that were tested here like this, and we could say, yeah, we've tested that clutch cover will definitely hold you know, 140 foot-pounds, and you spec your engine out and you're saying, well, I'm aiming for 130 foot-pounds in a boosted engine or something like that. Yeah, a 140 cover will give me 10 over what I need. And then you're going to be able to set your clutch as heavy as you require it, as opposed to going and buying, like, I mean, why would you use this clutch on an engine that's going to make 80 foot-pounds of torque? That wouldn't make any sense. We'd be better off with a lighter clutch cover, and then we could go down to, say, one that would hold 85 foot-pounds of torque, and then your motor makes 80 and that's it. Now, you never know really until you dyno your motor what it's going to make, so you're going to have to give yourself a bit of tolerance. But yeah, it's interesting to see all the different ones. So yeah, let me know in the comments below what you think about that. Do you think there'd be space for us to have tuned clutch covers? I think that might be an interesting one. Right, let's back off this torque wrench and strip off this, get this back in the jig and do a bit of drilling. Okay, well, that's worked reasonably well. We've gone through all 9 rivet holes. Pretty much no problems whatsoever. I definitely want to get this pin arrangement held because 1 or 2 of them went off center, and that's just simply because there is a bit of movement on this bearing, and when I'm holding it by hand, you know, it's allowing for a little bit of inaccuracy. The amount off center they went is so minuscule it won't make any difference whatsoever, because we're literally just drilling these rivets out. It's not like it's some sort of machining accuracy. When we get through them, we have to drill the holes for the threads. They do need to be accurate, but the pin itself, you know, once we get these bosses off, this will all come apart. So in the proof of concept is that this absolutely works and works brilliantly. I was able to just circle around all 9, bing, 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 drill them all, no problems whatsoever. Yes, as I said, I'd like to get this pin and plate working. It's worth going the extra mile and getting that to work, because it would be lovely to have it dead on center. I even think if we get that working, we won't need to center drill these. I think we'll just be able to go straight in with what I suppose is actually a center drill. I have one here, I think. One like that, nice short little stubby bit, and I think I could just go straight in with that on a slightly slower speed. If this was held firm enough, I think the whole machine would be able to do it. A good heavy center punch on the bosses. I'm also thinking that I might make a little center punching tool, you know, that sits over that rivet, and I can literally just go bang and it'll center punch the rivet dead center every time with a real heavy center punch, because the rivets are really soft. You can see by the filings that are coming off, they're real soft. What I'll do now is I'll use it again now just to drill the heads off these rivets, so I can take this apart and quickly show you what it looks like. Okay, so that's that last rivet taken out now. And this plate now is free. So this is going to give you an idea of how one of these clutches are built up. So this is that plate we were talking about. We drilled off the rivets. Next is the ring. So this is the pivot ring, and this is what allows the clutch diaphragm to pivot when you press your foot on the clutch. The diaphragm spring pivots on this ring. Next after that is the illustrious bit we wanted to get at, which is the actual diaphragm spring itself. Now obviously covered in oil filings and oil and everything now, because we have been working on it. You can see some of the features. We've got the holes here for the pullers, and then we've got the fingers of the diaphragm plate. The thickness of this is what gives us our clamping pressure. With that away, next thing you're going to see is we've got another pivot ring. This is the pivot ring underneath. So what that does is it sits underneath these so that the diaphragm can pivot on that ring and then this ring. So it's trapped effectively between the two with that one on top. Okay, so pivot ring, diaphragm plate, inner pivot ring. So that's the one that's on the inside here. And then these are the pillars I was talking to you about, these kind of spacer pillars. What this now has allowed us to do is to center drill these out in what is a nice accurate fashion. We now have our pressure plate back end is on here, and then we have our drillings here which are for our pillar tops. What you can see then hopefully is just how well our setup works. We can get this through 360. These are the pillars that we're going to have to make spacers for, so we have to make up our own versions of these. The plan will be to turn them in the lathe, so we're going to get some EN8 bar. I have EN8 bar ordered to come in this OD, so we can center drill it. I think I might even be able to get what's called gun drilled EN8, which means that it's actually a piece of stock bar with a hole all the way through it, which would be great. It means we just have to part it off on the lathe, then part off our 9 spacers, and that's where we go. There's another shop actually just outside town who are very good at making stuff like that as well, so I'm going to contact them to see whether they have a CNC lathe. They might just be able to turn these spacers off for us in one go. What I'm interested in is whether the height of these spacers is going to make a huge difference. When we start tuning this clutch, we may have to get a bunch of different spacers and different lengths made depending on how the clutch goes together. The simplest thing now basically is that what we're now able to do is we can have that pivot ring in there. We can have our diaphragm which is centered up on those bosses that we have made, or well, in this case are the rivet bosses. You then have your second pivot ring, and then you have a top off. What we want to be able to do now is to have a second diaphragm in there. So obviously this is just rough. We're just putting it together now with no cleaning or any preparation or anything like that. Then we will have our pivot ring, and we'll have our spacer plate then on top of that. So what we need to be able to do is we need to be able to create higher spacers so that they'll come up a little bit higher to center up both of the rings. As it is at the moment, they're only centering up one, so we need to make longer spacers to go in there. We need to take out those stubs that are in there, get rid of those, and drill, tap and thread this 6mm plate so that we can put bolts in instead of these rivets and finish it up. We're finally getting there. Very, very excited. If you managed to make it to this far in the video, thank you so much for sticking with us. Hopefully there's interesting information on it. We're finally getting there. We have a clutch come apart in our jig. We know the modifications we need to make to this plate in order to get it to work. On the next video with this, we'll have a look now at building up a RTS. So we're going to go make up a set of 9 spacers. It doesn't matter even if the gun barrel metal doesn't come through. We're only interested in making sure that all this system is going to work, so that when the clutch covers all arrive into stock, we'll be able to churn these out in a day or two and get them all made and done. So hopefully you're learning a bit about how these clutches work, and you're also seeing how we get tooled up. See you guys on the next one.